And welcome to Tvaritam.AI. In this video, we are going to talk about binning. And binning is a process of converting continuous numerical data into discrete categories or bins. So we are basically grouping a continuous data value into certain bins that makes it easier for the user to understand or interpret in a lot of cases. So something like temperature, which will have a numerical range, we can categorize it into cold, warm, extremely cold, extremely hot. Right. So these categories are created into continuous ranges using binning. This can reduce noise. It can also reduce the impact of outliers. It is useful to handle non-linear relationship. Obviously makes things easier to interpret, and it is useful for categorical algorithm. It is much more useful for those kind of algorithm where the prediction is categorical or that works better on categorical columns. Now common use cases could be grouping of age, income brackets into low, middle, high, credit score ranges into good, average, bad, temperature zones, temperate zones, warm zones, right? So this is how binning can be utilized in machine learning. One of the warning is that it can lead to loss of information, so it should be used only when required. It is not an essential step. You should use it if you see more interpretability opportunities, or you see that model performance is improving. You can try and see if the performance is better with binning or without binning. But because loss of information is a possibility and you want to keep all the data intact as it is, then binning might be something you can skip. Now, when it comes to binning, there are two important methods that we deal with. One is equal width binning. It divides range into bins of same width where each bin cover equal interval. So if you have a range from 0 to 100, you divide it into 5 bins, then it is 0 to 20, then 20 to 40, 40 to 60, 60 to 80, 80 to 100. So these 5 bins are created. All of them will have the same width. This is more useful when your data is uniformly distributed. It makes it intuitive and easy to understand the bins because it is much more straightforward in terms of how bins are created. But one issue that can occur with such kind of binning is that it can create unbalanced bin. We do not check where the data lies. We just check the range of data. So this can also create empty bins. For example, maybe there is no value that lies between 40 to 60. That particular bin will have no entry, and it is also sensitive to outliers. That means if there is a very large or a very small value, it might not be a perfect thing to go with equal width binning. The second alternative that we have when it comes to binning is equal frequency binning. Here each bin contains approximately same number of samples, also called as quantile binning. So what is quantile binning? We divide it into different bins depending on the number of samples and not the range of values. So if we have 100 samples, it could be from 0 to 100, it could be from 27 to 300. We will create 4 bins or 5 bins, but every bin will have same or similar number of samples. It is not exactly same in certain cases. Let us say if you have 70 values and you create 4 bins, then 70 cannot be divided into 4 equal bins. So there could be one value here and there. But the approximate distribution will always be same. The frequency approximately will match. It is more useful when data is skewed. Like in uniform data distribution, equal width makes more sense. Here if the data is skewed and you want a balanced representation, then equal frequency binning is a more sensible option. It is less intuitive than equal width binning, but in cases of skewed data, this is where you can balance the intuitiveness with the representation. So how to implement this? Well, you can just select the continuous feature that you have. First, we will go into the binning part and I can select, let us say, credit score. Now on the right hand side, it is easier for you to see the distribution, which makes you understand, okay, if the distribution is uniform or skewed. So you can also utilize the domain knowledge of what you know about the distribution or the variable or feature you are dealing with. But here in this distribution, I see uniformity. It is not highly skewed, right? As compared to, let us say, transaction amount, right? Here you can see the skewness is there to the right. So in terms of credit score, equal width binnings make more sense, and I will go with 4 equal bins. Click on apply, and now we have 4 bins. When we go with transaction amount, if I create equal bins of 4 and I click on apply, you will see that they have very different distribution. So in this case, what makes more sense is our equal frequency binning. I will go to the undo. I'll just undo this equal with binning. We'll go back again to our binning problem, going to the transaction amount, and this time we will use equal frequency binning. So this time we go with 4 bins again, and I click on apply. And now you see the frequency distribution for all the bins is almost similar. So this is how both the binning works, and you can utilize them. You can just select the feature and click on select which bin, which type of binning you want to go with, and number of bins you can also give. It depends on your domain knowledge, your idea. If you want to categorize, let us say, credit score into 4 different categories or 6 different categories, then you can see the number of bins. You can also do trial and test if you get more accuracy or better results with 4 bins, 8 bins, 12 bins. So these are the 2 ways, either using domain knowledge or your understanding of the data, or using trial and error. You can find what is the optimal number of bins in your problem. This was all about binning. Thank you for joining.